Hannah. I did. It's kind of, you can joke with me. That's fine. That's fine.
Say it, Mary Martha.
All right. Yeah, Mary Martha, go ahead. Hey, by the way, this is Coach Jay's podcast. Coach Jay's been, I think I got $12 already today. And a jacket, North Face jacket. So here we go. Section 7.1a. We're going to get into it today. And before we get into the hands-on activity, here's what I need from you. Remind me, okay? This is because we're going to build on top of this idea of statistic representing a parameter, having low variability, low bias. That's what creates a appropriate or correct, or I want to say correct statistic or a better statistic. That's there. So a statistic is a number computed from a what? Sample. Good. A parameter is a number computed from what, Mary Martha? Population. Rocking. Okay. Nice. Good. We will always use a what to estimate a what? We know.
Sample population.
Good.
Come on.
All right. A sample estimates a population. Very good. Okay. Now, someone other than this front table, someone tell me, in lesson 7.2, actually, you won't know this, so let me describe this for you, okay? We will be trying to estimate a proportion. With a statistic, we represent that using p hat, okay? So if I see p hat, that's how we call it, actually. P hat, we say is a statistic, okay? All right? Hat's backwards, it's all good. Okay? A parameter, what's that, Matthew? What's that?
Oh,
I have no idea.
P hat, there you are, right there. Parameter is just p, okay? So if we talk about a proportion and we say p, we're talking about the population. If we talk about a statistic, it's p hat, which is a representation of the complete parameter of p, okay? Now 7.3, we'll look at our final lesson. We'll look at a mean. We talked about that. A statistic is represented as what for a mean?
X bar.
X bar. Very good, Maddie. And Maddie, remind me, what's a parameter again? Mu, right? We talked about that. That is a parameter that's there. Okay. All of this is review and that sort of thing. Question though, why do we estimate a population with a sample? Why is that important?
So we can figure out how large the population is.
That
So
could
we don't overestimate or underestimate.
low bias, low bit. Cause
say that again, Mary Martha. I just want to continue that thought. You're right.
That was it. That was the end.
You rock that. That's good. Could someone else give me another reason why? Matthew, why?
The sample is like a representation of the population, so it's like a smaller part of it. So we should be able to use the sample to estimate the way the representation of a population.
Good. And why wouldn't I want to
Give me that.
just get? Well, let me continue with this. Why wouldn't I want to just find all of the pieces or all of the parameters of my population?
We'll give you a more precise answer, but it's like more convenient, or it's easier to use a sample.
Yeah, it's easier to represent a population with a sample. Sometimes it's possible to actually just find the parameter. That's absolutely true. But a lot of times it's not possible. It's really not possible. Sometimes it's not. If I was trying to find the difference between guys and girls study time within all of the high schools within America, that's impossible to really find that. Now, if I did GAC, that might be able to be possible, but it's still not a convenient thing to find if that was my population. So we use samples to be able to infer things about our population. That's why we do that there. Okay? Now, here's what we're going to do. Here's what I need. I'm going to give you a coin here, and I need you to flip the coin 20 times. When you are done, I think there's something on this side. Yes, beautiful. I need you to, you'll get a dot, and you're going to find the proportion of the times that you got heads, okay? So you're going to find out of 20, when you flip it 20 times, what's your proportion out of 20? You're going to take a dot, write that proportion on it, stick it on the top part here, just this part here, okay? That makes sense?
Yeah.
Here we go.
Do that, Campbell.
Here.
No.
Oh, money. Look at this.
What did you write? I feel like my returns.
Yes.
I wrote my
Yeah.
name wrong on
Wait,
mine.
I didn't make a good
You did?
Where's my instructions, bro?
I gave him
I
$1.
put mine in
Hey,
Sorry.
you wanna
How many do we do? How many?
Yes.
Wow. It's that kind of day.
Flip that coin.
Are you gonna know this is me?
1 for 1.
Mark here.
Yes, I will. You said on the ticket you wrote it from? On that?
Yeah. That's okay.
Mark it in the top left. There was
How many do we do?
5 for 7.
Flip it 20 times.
Can I have these? I think
No.
it's 4, so we all go.
1 for 8. I'm fine with that.
quarter. We're down.
9.
Yeah. You get a 9, sorry.
As we're flipping this coin, if you're at home right now, you could do this as well. You could flip the coin that's there, and as we go through this, we'll write it down right below on part E. So if you've got that, be a part of the activity. You could definitely do that there.
That's it.
Oh, that was a solid
9
win.
for 18.
1 for 4.
10 for 19.
3 for 11.
Oh my god.
11 for 12.
2 for 4. 5 for 7.
I'm gonna be an outlier.
4, 5. You got
Yeah.
9. You do that every time.
You get to that.
Oh, that was good.
Dude, that's
1 for 8.
6 for 10. How many times do I flip it? 20.
20.
6 for 10.
Wow.
9
I am horrible. 7 out of 20.
Oh, man.
I think my coin's rigged. This isn't working. Another one.
Oh my god. She's only gotten 2 fails.
17.
What's 7 out of
I have
15
2 more.
new?
I failed.
0.45. It's around there.
9 for
This is not good.
Not
I'm
good.
gonna mess up the.
Ended my coin flips there with 6 heads in a row.
I'm pretty disappointed with mine.
So the 7th one is
I
going
have
to be has to be
16.
No, it has to be a head.
What's that mean?
Because I just rolled 6 in a row.
Can you do mine?
By your back foot.
Wang.
Tails.
Has to be.
Well, heck doesn't it? Each is independent, right?
Yeah?
Independent of the other.
She
one.
got 16 out of 20.
16 out of 20.
No, Marvin Bagley though, he was at the free throw line the other day. You know who that is,
That's
right?
Yeah.
Yeah. He was at the free throw line and he was, I think, he was 2 for 6 and his average was 50. I bet my grandpa goes, I bet you $100 he makes 2 in a row right here.
Who?
Made 2 in a row.
Who was it?
50% free throw shooter. I was like, bet you.
That's pretty good.
Marvin Bagley.
Oh, because Bagley's so.
He
Wait,
was
which
2
game?
for 6.
Which game?
Yeah, he's pretty bad.
Portland State.
Oh, I was talking about game 2.
Hey, as we get this up, as we write this up here, if you could also get this down, just draw it right below, and you'll see, I think it's on part E. We'll talk through this, and then we're going to go to our second activity that's there. But I'm going to draw this up here for those that
Oh, you also tell?
are out here. I think Mary Martha had 0.8, which is pretty cool. Pretty good there. 0.55 is
Oh,
here.
we messed up.
I got 16.
We messed up. We have to write
What do you
the
mean?
percent.
Oh, the percent.
Not you. I don't know. If you
I did not.
Did you put the amount of makes you have?
Yeah, you know.
Divide, yeah.
So this is
0.55 is over here.
Divided by 20.
That's gonna be 0.6.
Okay, Wes.
Yeah, right
Okay.
there.
Wow.
I got
Alright.
15 heads to 5 tails. What do you
Wow.
Wes.
Still not
So-
good.
That's pretty good.
No,
rolling that 1d2?
I still win. I'm too competitive.
All right.
No one's gotten exactly 10.
I'm really
Got
good.
0.6. There we are.
Not
That's a little closer. Got another one here. We got 3.6s. Four.
You get one.
That's pretty good. Wow.
One got
Pretty
0.5.
I just.
What'd you get?
Number.
Matthew, what'd you get?
0.5.
0.5. Got you here.
No.
Okay.
You told me you got 16.
I did it again.
Oh, you did it again.
He's
Alright,
looking up
do it
numbers
again.
over there.
I did it again because I put it on the
I like
table the first time.
Okay, so let's have a conversation because this is important.
Talk about mine.
This is a population distribution, right?
Mhm.
What did we just do?
Flip the coin 20 times.
Okay.
That's
Jump,
not
James.
Question. Before we answer the question of whether this is a population distribution or not. Question. What is the population here?
all the
Coins.
time. The number
Wait.
of-
All coin tosses in the history of mankind that got head. I want you to put that down. All coin tosses
That's
in history of mankind. Okay?
That got head.
That get heads.
That get heads.
Okay?
Mankind is person kind.
Person kind. That's right.
That gets
I have no idea what you said.
2017.
All right. So with that being said,
Gender
Sexist.
equality or something right
Right
now?
now? Yeah, sexist.
oh,
Hey,
I'm
did you
sorry.
hear Matt Long's shout out?
Yeah.
On
Actually,
the radio, yeah.
Yeah. All right, real quick. Hey, right here. We gotta stay up here. Okay. I'm being distracted by you and your work. It's working. Okay. All right. So as we go through this, do you see how this would be an impossible population to find, right?
Yes, sir. Yeah.
Go to every person. in
Now,
mankind.
I would say yes. Okay. Yes. What is the parameter? Okay. What is the parameter that we're searching for? Or question: what is the mu that we're searching for? Or really, what is the true proportion that we're searching for?
The people in this classroom.
The pimple.
Well, remember, proportion is the whole, right? The whole. So wouldn't we be focused on the proportion? Great. The proportion of heads, right? So the proportion
Of the coins who get heads.
of heads when tossed. Okay? So that's what we're looking for. So, question, what is the sample that we just did?
20
Yeah, that's good.
flips.
We say 20 tosses. By the way, this right here in A, this is called our P, our parameter proportion, we call P. So with the sample, what is the statistic being used? Well, with that, we're going to call that P hat. Okay? P hat is the statistic being used. All right? All right, now when we recorded the proportion of heads here, I want you to put it right here. Now, what you see down below, when it says record the values, okay? The values can be seen down here, or you could see it up there. Just make sure you copy that down. You don't have to write it here. Just really copy this down here, okay? All right? I'm so worried about y'all. I'm so worried about y'all. All right, we got to keep going. We got to keep going. We got 10 minutes, okay?
Wait, what do we put for C?
For C, this is your proportion that's here. Okay? Alright, guys, let's stop. Alright? So question. Is that a population distribution or a sampling distribution?
Sample.
Okay?
But it's only a sample of the whole
Well-
population. You can't get the whole population of this.
Say that one more time.
It's only a sample of what population because you can't. This is too big to get the whole population in the world.
Correct. So could we
There's
say
no amount.
that what we just did
It's a population
up here is this, does this have lower bias?
If it's just for our classroom.
Okay.
There's some bias in there.
So I would say that the mean, if we were trying to find the mean, wouldn't you say it was about right in here?
Right.
Ish. Okay? So depending upon what we mean by low bias, it's impossible to eliminate bias, right?
Yeah.
Almost, practically impossible to eliminate bias. But we can come pretty doggone close by making it as small as possible. They say in the textbook eliminate bias, but technically that's not correct, but we'll just keep going. We did, the way we did it was random, right? We did 20 tosses, okay, on that. And I thought we did a pretty good job of sampling that. So the bias was okay. Does it have a low variability?
Yeah, possible.
I don't
I
know.
like that. Good, Matthew. I would say possibly, depending. All right, Jared, here we go. Ready? For you? Okay. How could I decrease the variability? That's a good question. How could I decrease this variability with what we just did?
Get the ticket.
How
Jared.
could I
Get the ticket.
decrease this variability? Maddie,
Is it to increase the population size? Or to increase the amount of trials or whatever?
exactly. Be careful with terminology. It's not increase the population. Population's everything. It's increasing the sample size, right? Because when we increase the sample size, we decrease the variability, right? Decrease the variability. Questions on that? All right, that was a good conversation. So we call this a sampling distribution because we took a sample and then we used it and put it in a distribution that you see there, okay? Within our proportion. So does this display bias? I would say it doesn't. I would say it doesn't, based upon the fact that how we flipped it, we did it randomly, right? Could we have done a better job? Maybe if we had more people, that might have helped out with the situation. Also, so I would say that the bias was low bias. I would say. Okay. The variability, was it high? I would say maybe, because the next question says, how could we decrease it? More samples or higher sample sizes? Max, you with me, my man? Just want to make sure you're with me. How can we decrease variability? We said it.
Increase the sample size.
Increase, so we say more samples?
No.
No. Higher sample sizes. Okay? Higher sample sizes. All right, also, someone explained to me, this is pretty good here. Why, and I said this yesterday a little bit, why is this, or those at home, why is this right here not a true sampling distribution? Rocket Man, let's go.
Because it only displays the sample of our classroom and not like the entire. If you did like the entire all coin tosses in the survey kind, that would be a true distribution, sampling distribution.
Correct. I would say too, I would highlight this. We're going to still call it a sampling distribution, but a true sampling distribution is taking all of the samples possible and putting it in to a distribution that you see up there. All possible coin tosses of size 20, all of them, that would be a true sampling distribution. True one. However, we'll call it this because is that possible?
No.
It's not possible, okay? But I just want to make sure you are aware of that. All right, you ready? Here we go. Next one, okay? Next one, average number of siblings, okay? Here's what I want you to do. Right now, you have a lot of dots around you. I want you to take the amount of siblings that you have, okay? Not including yourself. So it's possible to have 0. And I want you to put down that total number. I want you to come and stick that dot up here, right
Might
here.
be another outlier.
Dude, that's
What? You're not.
no.
No. Because that could get different. That could get a lot, okay? So we're just gonna say just siblings, okay?
Like blood.
Blood sibling.
Everyone in
Blood
this class
siblings.
is my family.
We'll do that.
That's not that.
Stick it up there on the board.
Yeah,
that's
if
right.
that's a family, then.
Three.
I
I thought you were being
Oh.
a child.
You become a child.